Lesson 12.2, Test for Independence and the Homogeneity of Proportions. The objectives for this lesson is to perform a test for independence and perform a test for homogeneity or of proportions. Let's look at our overview sheet and see where we're at for this chapter. In 12.1, we talked about the goodness of fit test. This is to test for frequency distributions that follows a specific distribution. The following two will be covered in this 12.2 lesson. 13.1 covers ANOVA. So we ask ourselves, is there a relationship between marital status and happiness? Here we have a contingency table. So to determine if there is a statistically significant association between two categorical variables, we perform a chi-square test of independence. Chi-square test for independence used to determine whether there is an association between a row variable and a column variable in a contingency table constructed from sample data. The null hypothesis is that the variables are independent. So happiness and marital status are independent of each other. The alternative is that happiness and marital status are dependent. So the variables are dependent is the alternative. The chi-square test for independence, just for an overview, it compares two characteristics from one population. The data below shows the marital status and happiness of individuals who participated in the General Social Survey. Compute the expected counts within each cell, assuming that marital status and happiness are independent. Down at the very bottom of this page, we have our steps. We're going to do it by hand by following steps 1 through 4, and then on our calculator we can check it. The reason why we're going to do it by hand is some of the homework questions have you do it by hand and you cannot use your calculator. So you will actually have to follow these steps in order to be able to do portions of it. So the first step was to compute the row and column totals. So this is a row, add those together, and get 919. Do that for each row. And then do that for each column. Step 2, compute the relative marginal frequencies for row variable and column variable. So if you look at just the rows, we're looking at very happy. What percentage of the surveyed responses was very happy? You take 919 divided by the total. The total is 2985. So when you take it by 2985, you get 0.3079. So about 31% was very happy. 0.5615 was pretty happy. and 0.1307 was not happy. You can check yourself, they all add up to 1. Then they want you to do in step 2 to do the same thing but for the columns now. So which proportion were married, widowed, divorced, separated, and then never married? If you add these together, they're again 2985. So 0.4734 were married, 0.0858 were widowed, 0.1963 were divorced, separated, and then 0.2446 were never married. Step 3, use the probability E and F equals the probability E times the probability F, the multiplication rule for independent events, to compute the expected proportion of observation within each cell, assuming independence. So what they're saying on step 3 is if we want to find the proportion that they're very happy and married, you're going to take 0.4734 times 0.3079. When you get that, you get 0.1457. So this is 1413, 2985. This times 919 over 2985. Okay, just note that we are rounding, so our final answer in this box is going to be a little different than what our calculator is going to show us because we are rounding here. For those that are very happy and widowed, you're going to take the 0.0858 times the 0.3079 to get 0.0264. Again, if you want to find very happy, so take 0.3079, now times it by 0.1963. Very happy again, so 0.3079 times 0.2446, 0.0753. Okay, I'll fill in the rest. I think you get the idea of how we're doing this now. Okay, now if you add all those up, you should get 1. And then if you added these up for your columns, that would have added up to 1 or close to 1. Step 4, multiply these proportions by the sample size. What is your sample size? Sample size is the 2985. Then equals 2985. So take 0.1457 times 2985. You should get 434.91. And then take each proportion times 2985. Okay, just make sure you check your answers with mine. See if we get the same answers. Now if you rounded yours a little differently, you're going to be a little off. That's okay. We're rounding. So up above was the observed, what we were given. These were observed, or you can call them counts, frequencies. Down below, what we just calculated was the expected, what we expect it to be. All right, and then let's verify on our calculator. So we're going to use step 21 on our calculator sheet. Go to second, matrix, edit, A. We have 3 rows and 4 columns. Now, type in the counts from the contingency table. So the counts was what was on or provided to us. Okay, once that's done, go to second mode to get to the main screen. Go to stats, tests, option C. The observed was an A. The expected is in B. The calculator is going to compute that for us. So go down to calculate. Here's the chi-squared test statistic and the p-value. We're going to get into that next. And then we want to look at matrix B. So go to second, matrix, edit, then go down to B. That should be filled in for you. Compare these values to what you just calculated. 435.02 was in the first row and column. That's pretty close to what we calculated. Now if we didn't round, so say we did these fractions and then times it by 2985, you would have got exactly 535.02 here. Okay. So if you want to go to the right, you can just go down into the matrix and then click to the right. And you can verify that these are all pretty close. The formula for finding expected frequencies in a chi-square test for independence is the expected frequency equaling the row total times the column total. I'll divide by the table total. The criteria should look familiar from 12.1. All the expected counts are greater than or equal to 1. That is the case, correct? They're all greater than or equal to 1. And then no more than 20% of the expected counts are less than 5. These are all greater than 5, so we don't need to worry about that. So the criteria are satisfied. The 5 steps for the chi-square test for independence. Step 1, determine the null and alternative hypotheses. The alternative is that the row variable and column variable are independent. The alternative is that the row variable and the column variable are dependent. Step 2, select the level of significance alpha depending on the seriousness of making a type 1 error. Step 3, calculate the expected frequencies for each cell in the contingency table. We just did that. Verify the criteria above. We just did that. And then compute the test statistic number 21 on the calculator sheet. We did do that, we just didn't look at the p-value, so we'd have to just retype it in. And then if the p-value is less than alpha, reject the null hypothesis, and then state the conclusion. So we are working with the same one. All expected frequencies are greater than or equal to 1. All right, we just calculated that, and then you can say no more than 20% of the expected frequencies are less than 5. The null hypothesis, We're going to compare the row and column. So the row is happiness, and the column is marital status, R, independent. Then the alternative is that the happiness and marital status are dependent. So the null will always be independent and the alternative will always be dependent. Step 2, your alpha is 0.05. Step 3, we can go back to test. And our chi-square is 224.116. P-value. Remember, p-value has to be less than or equal to 1. So when you see this, look all the way to the right. This means you're going to move the decimal 45 spots to the left. When you move 45 spots to the left, basically your p-value is 0. Take that p-value, compare it to your alpha. It is less than alpha, so we reject the null hypothesis. Step 5, we're going to state the conclusion. There is sufficient evidence at the alpha equaling 0.05 level of significance to conclude that happiness and marital status are dependent. Alright, we're going with the alternative, so we can say that they are dependent. Let's go back to page 8. On your homework, there's going to be a question on which of these contributed the most to the test statistic chi-square. So what you're going to want to do is look at the biggest difference. So if you take 600 and subtract the 435, that's a little over 150. So see which one has the largest difference. So widowed and very happy is a difference about of 15, 16. Go through all of them. Okay, once you've gone through all of them, you should notice that married and very happy had the largest difference. So what that means is that we expect about 435 to be married and very happy, but in reality we observed 600, which is quite higher. So this had the largest expected observed difference. This contributed the most to the test statistic chi-square. The observed 600 was greater than the expected. Means that marital status seems to have an effect on happiness level. Very happy and married had the largest expected observed difference.